Hello again, my name is Ben, and this is part 2 of our basic grid-based, turn-based movement tutorial. Well, last time we created the basic structure of our game with this grid. We filled out our perimeter with walls, and we added a player that will randomly jump between spots when we start the level. Today, what we're going to be doing is actually getting started on making our player move, which is very exciting. Not quite as exciting maybe as pathfinding, but it's up there. So let's start with a create event for the player. So I'm just going to fill out some of the basic important stuff that we're going to need. So, sorry, I'm not very good at typing and talking at the same time, so I'm going to have to do pauses there. So the first thing we're going to do is just create a reference to the controller object. I'm going to be referencing the controller constantly, and having to type out obj controller every time is just going to be a nuisance. So we're just going to make it C. We're also going to add some variables, can move, which will start out as true, and m speed, which we'll set to 4. So can move is just going to determine whether you're able to move or not, which is just like if I press an arrow key, am I able to, does it react in a movement? And that's determined by the can move variable. M speed is going to be a constant, and it is pretty much just going to determine how fast the player moves from one tile to the next. So our tiles are 20 by 20 in pixels. So m speed is just the pixels that we're going to move per step. So this is just going to mean we're going to move 4 pixels per step. So that means we're going to be moving, how many tiles or steps per tile? I don't know. It's 5. It's going to take 5 of these 5 steps to get through a tile. So yeah, I guess that's 5 steps per tile. I don't know. I'm confusing myself. So that's all for the create event for now. Most of what we're going to be doing is step, and we're also going to create some scripts. So first of all, we're going to start out by making some general reference variables to keyboard buttons. I just think that this is a useful thing to do. I won't make you watch me type this out over and over again. So the first real bit of code that I'm going to be doing is giving the player a reference to its own grid values, grid coordinates. And we're going to be putting them in like this. Okay, what did I mess up? Oh, right. Okay, so what this code here is going to be doing, is first of all, it's going to be getting its own grid coordinates by converting from its x coordinates, which is pixel, to grid. So now we have that stored in gx and gy, which is grid x and grid y. And then we're going to be updating the player's grid, which is going straight to the DS grid that the player created. And we're updating that with our variables. So now the 1 is there. So this means that anytime the player moves, it's going to be updated. But we want to be careful with that because we don't want to make it so that this is happening constantly. We just want to make it so it's happening, as often as it needs to be. So something that's going to be important is, what am I doing? We're going to be putting this in this if statement that's basically just checking if the player is currently moving or not. So this is just going to make it so the player can't update its grid coordinates while it's moving. The reason why that's going to be is because we just want to make it so that we're always very accurate with our grid coordinates so that we can make accurate references, I guess. And if we have the player being able to update itself while it's moving, it's going to get really, really ugly and weird. So the best way to do this is to just make it so when the player does move, just clear the current value from 1 to 0 so that it's not there anymore. And then as soon as it's done moving and into the next space, then it just will update itself because it will no longer be moving, and then it'll be doing its thing. So this is just a good way of doing it. So now that that's done, we have a reference now to our grid coordinates, which is going to be really useful for the next bit of code, which is going to be the actual movement. So first things first, we're going to have a check that's just if can move. So all that means is if the player is able to move, then we can do move stuff. So now we're going to start checking for our keyboards. But we need to check for more than just the keyboard inputs. We also need to check if there's collisions. Now, there isn't an easy way to do collisions. Well, there is an easy way, but there isn't like a built-in thing for doing collisions on grids. So we're going to have to make our own script for that. Hold on, I'll explain this in a second. There's a couple scripts here that's happening actually. Okay, I'm assuming this is mad about this. Yeah, so we're going to be doing two different scripts here. So first we're going to say if the player is able to move, okay, cool. If the right key, as in the right arrow key, has been pressed, and there is not a collision that is equal to 3 at coordinate gx, which is the player's current coordinate, plus 1, so it's directly to the right of the player, and no up or down. So it's just checking to the right whether it is a wall. So this is exactly a wall, what this 3 means, because if you remember from our initial creation of the walls, we set them to 3 right here. And yeah, so walls are 3, player 1, enemies, yada, yada, yada. The reason why we're not checking for enemies is because we're not going to be doing typical collisions for enemies. We're going to make it so later on we're going to update this code to say if right and an enemy is there, then attack it. Otherwise, check for a wall and then move if there's not a wall. So that's how that's going to work. But let's just go ahead and finish this, and then we'll go ahead and make our scripts. So now we're going to check for down, which is going to be that. And again, this is why I was saying clockwise is helpful, because the way that I'm going to be doing this script, the move script, is it's going to be the parameter that you put in, or the argument is going to be, it's going to be a direction, a lateral direction, where 0 is right, 1 is down, 2 is left, and 3 is up. So that's why I'm doing that. So now we're going to do left, which is going to be -1. So again, gx -1 is going to be to the left. Gx neutral, gx plus, or gy +1, that's below the player. So this will be that. And then lastly, we will do up, which will be above the player, and that'll be a 3. Okay, so that's the movement code for now. Now let's actually make it do stuff. So first things first, we'll make our collision script first. So for that, we'll do check grid collision. And if you're not familiar, when you do these triple forward slashes at the top, that'll actually make it so you can have like a keyword search when you're doing scripts. So it'll actually show you what the parameters are. It's pretty helpful. I didn't know that until relatively recently. So what this is going to be, it's going to check, you're going to input a grid x coordinate, so not a pixel coordinate, a grid coordinate, a grid y coordinate, and the type of collision that you're checking for. The only reason that it's doing type is just because, again, when we do attacks, it's going to be relevant that it's an enemy versus a wall and vice versa. So we're going to go ahead and get our arguments. I don't remember, I had this written down as C, and I don't remember why I had it as C. I'm going to leave it for now, I guess. Oh, I think I had it as collision. I'm going to change it to T. I like that better. So, well, I guess I should explain. So all this is going to be, we're just going to reference the obj controller.grid, and we're going to have it check whatever our things are, and then check for if it is equal to this type. So we're going to get the value at gx, gy, and see if it is equal to t. And if so, return true. Otherwise, return false. So all this is just a binary function that just checks if there is a collision or not, and then it returns it. So nice and simple. Yeah. So let's make sure I actually spelled that stuff right. So now this should be good. Yep, now it doesn't know what move is. So of course when you look here it says grid x coordinate, grid y coordinate type. Good stuff. So the move one will be a little bit longer, not that much though. So only one argument. And basically all that we're going to be doing here is just saying, like, we're going to take in whatever the argument is, and depending on what the direction is, we're going to have the player start moving in that direction, and we're going to have the player clear out its current grid location in the grid so that it's emptied and it's moved so that for future collisions, enemies will know where to find the player. And then we also need to make sure that we have a way to stop the player. So we need to make an accurate timer that is anticipating where the player will stop so that we can make sure that the grid is always synced and that the player is moving correctly. So first things first, let's just start doing this. And again, this is m speed again. So we're just setting our speed to m speed. So that was that constant earlier. It's currently equal to 4, which means it'll be moving at 4 pixels per step, which means it'll be going through from one tile to the next in 5 steps, which is like, gosh, hold on. It's a short amount of time. It's pretty fast. You can always update it to whatever you want if you want to make it faster, as long as it's, divisible by whatever your dimensions are. So we're just going to do this stuff. I'm just assuming that this makes sense because this isn't super complicated. So yeah, it's just going through whatever our things are and then moving the player relative to our input. So now we're going to also go ahead and clear the grid spot. So remember 0 is empty, so now that the player is moving off of the current location, the gx and gy, which remember are still exactly the same, even though the player is going to be moving, it's not actually going to update the gx or the gy until the player stops moving again. So this is why this is helpful, because if we clear it out now and the player is able to continue to update it while it's moving, it's just going to reset it to wherever it was just now. So like, imagine right when the player does move, it clears this thing out and it moves 4 pixels, and then it goes back into step, and it goes through here. It goes back into step. It doesn't need to check for this in this hypothetical, and it resets it to whatever the current gx/gy is of pixel to grid, which is just going to be really messy, and yeah, it's just bad. It needs to be done. And then lastly, so what this is doing is this is calculating exactly how much time is needed for the player to make it from one tile to the next, which is basically just 5. So c.dem, objcontroller.dem, dem is dimensions, so it's 20 pixels. So this is 20 divided by m speed, which is 4, so that math goes out to 5. So this is basically just setting an alarm for 5 steps, which is exactly how much time that is needed for the player to move to the next tile. So once this alarm goes off, we're going to be stopping the player and then preparing it to be able to move again by resetting can move. Because remember, can move is Well, it's not false yet, but it's about to be. Yeah, so now that this has started, the player can't move anymore because the player is already moving. So yeah, we'll just go ahead and okay. So now, I almost, hold on. There. So now our player should be close to being good. Close. The last thing that we really need to do is our alarm, which is what's going to stop the player from moving. So let's do that. So this is once the player has finished, is prepared to finish moving. So immediately what we need to do, well, here. So this here this'll work, but I don't particularly like it because it's too fast, as you'll see here. So like it works, the collisions are good, as you can see. And if we go into the debug mode, so we can actually see our grid in action. So, well, one thing, it's weird, it actually isn't, since we're never not moving, our position actually never updates. That being said, it doesn't matter yet that that's the case, because we're only checking, the only thing that gets checked is other solids, the walls, not the player. But we'll need to stop that. We need to make it so the player has a moment to actually pause between movements, because this is a turn-based game, so we don't want the player to be able to just zip around like this. So the way we're going to do that is by adding a sort of buffer. So we're going to say okay, so here's what this is doing. So all that we changed is we made it so that the player only stops moving if they're already moving. But the player can't move again when this happens. So there's a 10-step break where the player is stopped moving and can't move again. But once that break ends, they can move again. So now what we'll end up with is sort of a lurched movement, I guess, where you'll be forced to pause. Yeah, like that. So now you'll notice that there is a noticeable moment where the player has time to update itself. And if you hold the button in whichever direction against the walls, it will work. You'll also notice the player can't move diagonally if you hold both buttons. If for whatever reason you want to change that, all you need to do is remove these else's so that it can check for multiple at once. So for instance, if it checks right and right works, then it does it. And then if it checks down as well, then it does it as well. So then you'll move right and down. I wouldn't recommend that personally, especially for the system that I'm going to be creating for these tutorials. It's not going to work out super good, but I mean, if you want to, I guess you can. You know, there's nothing stopping you. But yeah, that is going to be it for this one. I hope that this is helpful and enlightening. In the next bit, we are going to be starting to place creating our enemies and creating a parent enemy object so that we can make it easy to create new types of enemies in the future that have different statistics. And we will start getting it so we're not going to do pathfinding quite yet, but we're going to make it so the player can attack the enemies, and we're going to give enemies HP and stuff like that so that they'll actually be able to die. So it'll be good. And then after that, in the fourth part, we'll be doing enemy pathfinding so that the enemies can fight us and that we can die. And then in the final part, we'll just be doing some cleanup stuff like items, more random generation, level progression. We'll make it so that we can make some more enemies. We'll make it so the player is more editable. Currently, the player can only move. The player statistics don't matter right now because there's no enemies, but we'll be able to modify the game slightly so that the player can make multiple movements in a turn when an enemy can only make one. And then, make multiple free movements, free actions before the enemies have to move. And HP, damage, etc. Stuff like that. So it's good. So that's what's happening next. Thank you for watching. I hope it was helpful, and see you then.